We're live and welcome back to another exam walkthrough. We're going to be going through 2021 June Unit 2, question number 16. This question is going to be about polarization. So I want you to pause the video, try the question yourself, and if you want to go for the Marxian examiner report, you can go to the end of the video. So this is question number 16. It says, when unpolarized light passes through a polarizing filter, the light becomes plane polarized. And they tell you, explain the difference between unpolarized and plane polarized light. This is a repeated question and it has the same mark scheme every year. So I'm just going to write it down and I hope you understand it. Okay, so it says here, first mark you get is that unpolarized light has oscillations in all directions. You can also say vibrations. And then plane polarized light has oscillation in only one direction. And then the direction of wave travel is perpendicular to the direction of oscillation. You have studied this even in IGCSE in transverse waves, that the direction in which the wave moves, a transverse wave, is going to be perpendicular to the direction of the oscillation. So the wave is moving in this direction, it's oscillating up and down. You can see there's a 90-degree angle, both are perpendicular. And then we know this as well, that unpolarized light has oscillations in all directions and a plane polarized light has oscillation in only one direction. So I want you to understand this and then memorize it. This is repeated a lot and it's usually at the start of the polarization question they ask this. Okay, so let's move on to the next part now. Part B, it says an unpolarized light source is directed towards a screen. The intensity of radiation is going to be 1 watt per meter square. And then the question tells us two polarizing filters are placed between the light source and the screen. And initially there is an angle 0 degrees between the planes of polarization as shown, between their planes of polarization. And then one of the polarizing filters is rotated. And then it says sketch a graph to show how the intensity measured at the screen varies as the filter is rotated from 0 to 90 degree. And here is a graph of intensity against rotation angle. So typically students find this a bit difficult. So I have a few diagrams to help you understand. So here we have the first polarizing filter and I have the second polarizing filter. And the light passes through both of them. And this is the polarizing filter that's going to be rotated. So the polarizing filter is going to be rotated. And notice at first they both are parallel to each other. And then they become, their transmission axes become perpendicular. So this is going to be vertical transmission axis and this is going to be a horizontal transmission axis. And both of them are going to be perpendicular. But initially they were parallel because you rotate this from 0 degree here to 90 degree over here. Now, we know that the light intensity initially is going to be I naught. And that intensity is 1.00 watts per meter square. And then when the light passes through the first polarizing filter, its intensity is going to be reduced by half. So it's going to be 0.50 watts meter square. And then the same light will just pass through and it's going to remain at 0.5 watts meter square. Okay, and the same thing is going to take place down here as well. 0.5 here. Now, when you rotate it till 90 degree, what's going to happen is you can notice that this is going to be vertically plane polarized light right over here. It has oscillations in the vertical direction. And the polarizing filter will only allow horizontally plane polarized light to pass through. The rest of the oscillations will be absorbed. Right? So this light here that has the oscillations in the vertical direction is going to be absorbed and the intensity is going to become 0. Okay? So when we're at 0 degree, our intensity is going to be 0.5. And then when we're at 90 degree, it's going to become minimum. So we go from max and we're going to go minimum. So something like this. So that's going to be your graph. Okay, and now we're going to go to the next part, part C. Okay, I hope that other part was clear, okay, because that was a bit tricky. So here it says polarization can be used to identify when some materials are under stress. Placing the material under stress causes the plane of polarization of the light passing through the material to be rotated. The greater the stress, the greater the rotation of the plane of the polarization of the light. Let's read this very carefully. Very important point. And it says a piece of transparent material under stress is positioned between two polarizing filters. There is an angle of 90 degrees between the planes of polarization of the two polarizing filters. Explain how this photograph can be used to identify areas of the material with different amounts of stress. Okay, now when both of the polarizing filters are at an angle of 90 degrees, we know that the intensity of light is going to be 0. Okay, so we can write that for 1 mark. So polarizing filters at 90 degrees do not allow light to pass through, so the intensity is going to be 0. So here I have a diagram to help you understand this. So we can see here that when both the polarizing filters are going to be 90 degrees to each other, no light is going to pass through. But then when we put a little stress, it's going to cause the polarizing filter to rotate. And when that rotation happens, you can expect some of the light to pass through. So the intensity of light will increase. And how we can tell this is using the graph as well. You can see at 90, they're going to have the intensity 0. No light will pass through. But then if the angle changes by a bit, so if the angle becomes 80, 70, then there's going to be intensity of light. And the more the stress, the more the polarizing filter will be rotated, right? The more the polarizing filter will be rotated and the angle will change. And the more this angle changes, so it becomes, let's say 80, changes by 10 degree, 20 degree, 30 degree, the more it changes, the more the intensity will be. And the less the angle change there is, the less the intensity of the light there will be. So rotation of polarizing filters due to stress allows light to pass through. So the intensity will be greater than 0. Now more stress means that there is more light, so the area will be brighter. And less stress means that there is less light, so it represents a darker area. So you're going to get 1 mark for this, 1 mark for this, and 1 mark for this. So make sure you understand this application very well. And now I'm going to show you the mark scheme and the examiner report.